Well, I guess we are live now, and in this, live video, what we will discuss is about some of the important questions in linked list that is most oftenly asked in multinational companies. And in recent interview of mine, there was one question of reversing a linked list, how you can reverse a linked list. So we will try to solve some of the questions today, and before solving the questions, let's create a linked list. First is to create a node, then after putting the data into it, and another part would be the address, that is nothing but we'll give it a name of next. So now we will create a function called create of what type, that would be of a node type. Node is a user defined data type that we have created here, and within this we will give two things, that is the header part and then after the data part. Now we will dynamically create uh, or give memory to it, to the particular new node, that is this new node, right? Now which would be the type of node. Superb. Actually this new is only available in C++. If it's C, you have to use malloc, which is nothing but node star malloc and then size of node. Yeah, so this is actually called as the explicit type, because we are specifying the node's memory to it, and this is called the implicit type. The compiler itself defines the space to it. Now we will give the data to the data part. This is called as the this pointer, right? Yeah, super. Now what we will do is that new nodes next would be head, and head would be equal to the new node. Return new node. Super. Now this the what it is returning is a new node, which is nothing but a type of node, and since in this function the return type is node, so yeah, we are heading towards a good start. Now we will try to print it, and let's see. We will normally create a with a while loop. Let's suppose the head is null, so it will directly return, and then if head is not equal to null, suppose, yeah, then semicolon, then cout head data. Okay, instead of head we should often make the practice of writing temp. Yeah, and we may copy this. Yeah, so now temp is equal to temps next. I think this should work now. Let's try to write try to make a linked list by using an array. We will create an array and write random numbers to it. Then after we will create a head pointer which will lead to null, and then after for auto I in array, what we will do is that head should be equal to create of head comma date I. If you have any doubt, actually I have discussed more about creating a linked list in the previous video, you can check that out. And then after we will print it. Now let's try. The build is successful. It takes a little time to print at the beginning. Okay, the struct nodes next should be head. Yeah, head is new node now. Yes, you can see it is printing. The thing is that we have to give some space after every single number. Yes, you can see it is printing 1232 in the reverse order. Now the first question is how you can print the whole thing in reverse, right? Now one of the thing to to reverse a linked list or reverse anything is by using stacks, right? One is that, so what is stack is nothing but a data structure in which like a stack of plate, stack of book. So what a stack follows is that what goes first into the stack comes last, right? Suppose there are 5 books, so the first book that you place first, right, would be popped up in the last. So similarly, so it will print the whole list in the reverse order. Now similarly, another way of doing that is by using recursion, right? So even recursion uses stack in the backend. uh, Now let's try to print it. Void reverse print, and then we will pass the head pointer to it. Then after, what we will do is if the head is equal to yeah equal to null, it will just eventually return. Then after, if not, right, so it should call it recursively. So we can copy this whole thing, and then after we will pass the head pointers next, and yeah, after that we will print the heads data, and then we will give a space to it. So yeah, we will give an end line, another extraction symbol, then after reverse print, and then we will pass the head pointer, right? Now what is happening in this code, you can see that I have passed the head pointer, that is the first, right? And if it's null, it will return eventually, but if it's not, then it will go to the reverse this reverse, that is the line number 33. So it will go to the next node, and it will do that again. Eventually it will keep on doing the same thing until and unless this value comes, that is nothing but the last value, right? If this will return, so so the last value, suppose this is the linked list, it will keep on gonna traverse, and when it reaches to the last one, it will return. So when it returns, it will return after this line, right? And after this line, what is the next line? That is the cout. So it will print the last number, and it will keep on, since it is, this whole thing is going into a stack in the backend actually, right? Whensoever we talk about recursion, it goes into the stack data structure. So eventually, what is stack, what goes first will come out last, right? So suppose the left to right, the linked list is from left to right, so left part goes first into the stack, so it will pop out, it will print in the last. Now let's try to run the code, and let's see is it working or not. Well guys, you can see that the code is running and it is printing the reverse of the linked list, right? Now the second important one is to find the sum of the whole linked list. I mean, what would be the sum of the nodes, right? So you can see one of the basic thing is you have to traverse, right? So within that we can add a sum value. You can create int sum is equal to 0, right? And then after, whensoever you recurse, you in the sprint function, right, you just have to add one more line, that is sum plus is equal to temp data. That's it. Yeah. So sum plus is nothing but a shorthand, that is sum is equal to sum plus temp data. So it will keep on adding until and unless it reaches to 10, and then after we will have the value of sum, and at the end we can here print that sum is sum. The reason we can write the sum part here is because we have initialized the sum in global, right? That is outside the brackets of the int main. Now let's try to print, and you can see the sum of the number is printing 435, right? So the sum of this whole number is actually 435. Let's try to check. 12 plus 32 plus 34 plus 56 plus 234 plus 67. Superb. You can see it is printing that the sum is 435, and here in our code also it is printing 435. Now let's try to see, since it is a array that we are passing, but what if it is in runtime, right? What if someone is adding the numbers and we have to count how many nodes are there? So there is no clue and there is no idea. So, and whenever we talk about data, it's in since here we are dealing with very few numbers, but in the real world there are many numbers, there are many humongous amount of data in TBs or in GBs. So how we can count, rather than what you have to do is that you just have to change the sum count into adding a count here, and count plus should be equal to 1. That's it. And we can initialize a count outside this bracket, and then after we can you can copy this whole thing and you can modify in beneath, and L count is count, and L, yeah, super. And L count. I don't know why it is showing failed. Okay, rather than using, actually we have written a comma here, right? So we can't write int again. Okay, actually when we are using this bits std c++, there is already a count keyword, so we can't use the count word, so we will write cnt maybe. And you can see the error that is showing here, that is ambiguity or ambiguous, right? So we'll try to change it to cnt. Let's try to run now. You can see it is succeeding, and you can see there are 1 2 3 4 5 6, so the count is showing up 6, right? So till now we have encountered 3 problems, and we will see the very important one and the third one, that is to get the middle element or the middle node of a particular linked list. Because when it comes to an array, you have the whole range, you have the first node and the last node. So if you just divide the last node, then you will be able to get the middle part, but the case is not exactly like here. Well, basically there's one method called as the rabbit and what was that, a slow and fast method. Basically uh, there are 2 pointers which is pointing to the head pointer at initial, then after one pointer will run fast and another pointer will run slow. So when the fast pointer reaches to the last node, then the middle or the slow pointer will reach to the middle node. Now let's see programmatically first how does it works. Void mid, and we will pass the node head, and then after we'll create 2 slow and fast pointers, which will be equal to head, and then after fast, which will be equal to head. Yeah, super. And instead of this we will write node star, because it will return a node, right? And while the condition will be while fast is not equal to null, and yeah, fast next is not equal to null. The reason of writing two conditions is because suppose they are even numbers, right? So there is no middle part, so there should be, you know, one middle part, right? Either suppose there are six elements here itself, right? So there are two middles, so what we have to give the middle part to this one or to this one. That's the reason we have added another condition. Now yeah, we will, you know, traverse slow is equal to slows next, and then after fast is equal to fast next. We will write 2 next because it will, you know, it is one step ahead of the slow. So when it reaches the condition, we will return the slow. Now since it's an odd, you know, since it's an even number of nodes, so there should be one, you know, a middle part. So we will add another element to it, and we will, you know, print the mid part. I don't know if we can do this or not. Let's try. Okay, yes, you can see this is the last node. I mean, this is the last linked list, right? And the node which is in the middle is nothing but 56, and the count is this, etc, etc, and at the last it is printing 56. Now basically what happens is that, let me, you know, open my notes. Yeah, you can see this is a linked list, and rather than this, you know, I will add new just numbers. Okay, like 12, 13, 14, 122. Yeah, none. Super. Now let's increase the height of it. Okay, super. Now what happens first is that both the slow pointer as well as the fast pointer are pointing here, right? So this is the slow pointer, this is the fast pointer. At first iteration, you can see in the code also parallelly. Yeah, this is the code, right? So after first iteration, slow is in the next, that is here, right? Okay, so slow is here now after first iteration, but fast is here, right? Then after slow is here, and then fast is here. After that slow would be here, and then fast would be reaching to here. Now you can see when the fast reaches here, it is returning the value of slow. So at last the slow was pointing here, therefore this would be called as the middle node of the whole linked list. Basically there was a story, you know, of a rabbit and a tortoise, right? So this is famous, and it is famously called as the tortoise and the hare method, right? Now we will try to solve one of the important and one of the asked question, and the popular one of reversing a linked list. Basically what is reversing a linked list, guys? Let me pop in the code again. Yeah, suppose this is the linked list, right? And suppose this element is pointed to this, and eventually it is pointed to null. Now what you have to do is that you have to reverse the whole arrow. The arrow should be here, it should be pointing here, and we have to erase this. Okay, this is not the erase one. Yeah, we have to erase this, and eventually we have to keep on doing the same thing. The arrow should be pointing here. So let me share you a GIF now, a small clip which will help you to understand how it is working. Okay, yeah. You can see that there are 3 pointers. One is a previous, next, and a current pointer. Initially the current pointer is pointing to the head, and then after it is pointing to, then after what will happen is that the next will point to the next of the current. In the code you can see here, then after the the current would point to the previous, and then the previous will go to the next, and the current will be equivalent to, here you can see the current would equate to next. So current and next are pointing to the same thing. Now it will recurse, it will go to the second iteration, and it will keep on doing the same thing. And you can see, because of current is pointing to the previous one, the arrow is going uh, going in the left side rather than going in the right side. Now the basic idea is that you need to have 3 pointers, so that you can even go to the starting, you can go one step ahead, and you can connect one step in the previous. So that's the reason we are taking 3 pointers. As the name, you can see the previous, that is in the behind one, and the current, which is actually involving in uh, pointing to the previous one, and the next one we are having as a as a reference, because the current will go to the next. Now let's try to code and to find how to reverse the whole linked list. Reverse ll, and we will give the header part. Now the what are the 3 things? One is the previous, another one is the next, and a current which will point to head. We will use double pointer here. The reason is because we have to change the linked list, right? Whensoever there is a change in the linked list, and so we often use double pointer, and yeah, we have to use star here. So now we will have a while loop, and the while loop should run until and unless the value of current becomes null, right? The first thing was that the current the next should be equal to the, sorry, yeah, the next pointer should be equal to the current's next pointer, yeah, and then after the current next should be point to previous. Then after the the previous would jump to current, and then the current would jump again to the next. Yeah, it should work. And then after the head should point to the previous node. So this code, I guess, would reverse the whole linked list. Now let's try to pass the head, not just the head, but we have to write an ampersand. The reason is because we are using double pointer in the code, right? Yeah. Now in this part, you can see in here the linked list is reversed, right? Yeah, so the linked list is reversed in this part. Now we have to add a print function to it. Print print function, and we will pass the head to this function. Now let's try to print, and let's see does the code works or not. You can see this GIF here, guys, with animation. Yeah, yes, you can see. Okay, print data, yeah, okay. the currents next is previous, then previous would be equal to current, and then current would be next, and this will run until and unless the current not equal to null. Now the reason it is showing an error here is because we have to add another condition that the temp next should not be equal to null. Yeah, temp next, right? Yeah, temps next. Or else we can remove this. Well, you can see here that the array was, is it okay? There is a small error. We can remove this whole thing, the sum part, mid part. Okay, now let's try to do it now. Okay, we gotta remove this data. If temps next is not equal to null, if the temp is equal to null, it should return. If the temp next is equal to null, actually and this mid part, we have to remove this. Now let's try. Actually, you can see here that it is reversing the whole linked list here, right? First it was 78 and it is coming in the end, then it was 67 and it is coming to the end, then 234 it is coming to the end. So eventually the linked list is reversed, but the thing is that we have to write another condition that I'm missing here, of to eliminate this one. Yeah, I think I should write and temp should not be equal to null. Yeah, rather than using or, I should use and. Okay, temp next should not be equal to null. Okay, rather than using this print function, let's try to print in the reverse order. Okay, reverse print, and now let's print. Okay, the problem is in the condition itself. Well, you know what, we will try to solve this issue here. Though we have achieved our goal of reversing the linked list, this is the particular code for it, right? Here what we are doing is that we are okay. Yeah, so here what we are doing is that we are actually I think we have to return the node star. Do we? I think we have to. Let's return the node of head pointer. Well, you know what, void is better, because the main motive of doing this was to reverse the linked list, right? And we have achieved that. The slight change that we have to do is in the print function, that we will talk in the later video. Well guys, I hope you find this video informative. If you do find this video informative, don't forget to like, share and subscribe to my channel Developer Geeks Hub. Well, we are going